I hope you all went through the previous week's YouTube recording of the session because we had left off at question 8, correct? Did you check this? Is my screen visible? Yep. So, welcome you all to the seventh uh, live interaction session for the course Principles of Downstream Techniques in Bioprocess. So, before I start with this week's session, I thought we'd go over the two questions that were left last week, just before we ended that session. Sorry. Yes, this one. So let me go into presentation mode. This was what was written in the video. Do you want me to erase this and work this out again? So last time we were at this stage. Correct. I brought 1 to this side and instead of 1.5 had written as 1.05, and then I was wondering how n plus 1 would be equal to 1, so n would be 0. Right? So that was an error, a rather silly mistake, I would say. So if you take 1.5 to this side, so let me repeat the question again. How many stages of counter current extractor is needed? Answer in whole numbers to extract 90% of the protein. So XR by XF is equal to zero point 0.1, right? And the rate of broth is 400 liters per hour and it is extracted with 35 liters per hour of solvent. So you have E value right there. SK by F is equal to 1.05 and partition coefficient is equal to 12. So you substitute that and get 1.05. Then we substitute it into the counter current formula, and when you solve for it you get 1.05 power n plus 1 is equal to 1.5. And when we take out the ln, when you raise it to the power of when you take it out from the power with log or ln, you end up with n is equal to 8 stages. Clear? And question 9 was in continuation with 8. If I use another solvent in problem 8 so that the partition coefficient is doubled, so instead of 12 there you're going to substitute 24 and get the answer as 2.1, which is double that of 1.5, right? So if you substitute that and solve the same way as the previous question, you end up with n is equal to 3.6, n plus 1 is equal to 3.6, sorry. So n is equal to 2.6, so we round it off to 3 stages. Clear? Also, I had replaced question number 4 or 3, maybe. Yes. So I don't know whether you went through this question also. Two solutes A and B are present in a broth at 0.9 and zero point 0.8 millimolar concentration respectively. When a solvent is added for extracting, then then 0.6 millimolar of A and zero point 0.4 millimolar of B are extracted. What is the separation factor? B to A. So separation factor, how do you get it? Beta is the ratio of K, right? Partition coefficient. So since it is B to A, it is KB by Ka. And how do you find K in the extract? By raffinate. And what do you have? You have what is there in the feed, and you know what is there in the extract. So extract you can directly substitute, but for raffinate, what should you do? Amount present in raffinate is equal to feed minus extract. So if you do that for Ka and Kb, you can find beta. Okay, you can always refer to this in the YouTube recording. So with that, we are going to go into today's session. Is everybody clear with question 3, 8 and 9? Do you want me to repeat anything? Okay. All right. So let's go into of today's session. This week's set of questions. This week we have liquid extraction, reversed micellar and aqueous two-phase extraction, and membranes as our topic. And I think we have just 7 questions with one numerical. Jumping right into the first question, which is not a non-bonded interaction? Take a minute, use the chat box, and drop in your options. Is it A, hydrophobic, B, electrostatic, C, covalent, and D, hydrogen? Which is not a non-bonded. So you have double negatives there. What does that mean? Which is a bonded, right? So which of these is a bonded interaction? Hydrophobic, electrostatic, covalent, or hydrogen? So think which one of these is the strongest, right? There are 3 weak interactions, some not so weak, some little medium strong, but one bond which is very strong. And that is your answer. Any guesses? First of all, hydrophobic and electrostatic, you don't call it bonded, right? You just call it hydrophobic interaction or electrostatic interactions. They are not concrete bonds. These are just preferred modes of interactions. However, you do hear hydrogen bond and covalent bond, right? Of which hydrogen bond is weaker than covalent bond, and hydrogen bond is not as specific as covalent bonding, right? So, option is C. Any disagreements? Okay. Question 2. Which membrane does not have pores? Microfiltration, ultrafiltration, evaporation, or dialysis? Guys, this is a very simple question, no? Which membrane does not have pores? Obviously, we would expect all filtration membranes to have pores, right? That's the whole point of filtering something. So you're trying to sieve something, like let some parts of a solution pass and prevent others from going. So which membrane does not have pores at all? Think about each process. Both in microfiltration and ultrafiltration, you are going to let some of the solution pass through the membrane, right? In liquid forms. So the membranes should have pores. So it is not going to be microfiltration or ultrafiltration. And dialysis, again, you're exchanging salt, other urea, uric acid, nitrogenous wastes, other toxic compounds, drug molecules with the external solvent. And where is it coming from? From the blood to an external medium, that is that works as a replacement for kidneys. So the dialysis membranes help in filtration of the toxic components from the body. So again, it has pores. This one, although very small and very selective, they do have pores. So this is not your option. What happens in the case of evaporation? These membranes are almost like solid, right? They are not porous, and your extraction is based on bringing one of the components to a vapor phase, right? The pressure is adjusted such a manner that one of the components goes into the vapor phase, and that vapor can diffuse through the membrane. However, the membrane as such does not have pores, correct? So option is C, evaporation. Okay, shall we move on to the next question? So this is very simple. So I'm going to wait until one of you answer. Which technique is used for desalination of seawater? Option A, microfiltration. Thank you, Shriram. Somebody else? Option B, ultrafiltration. C, reverse osmosis. And D, nanofiltration. I mean, I need to know at least if you guys are awake, right? It's Friday evening, slowly ebbing into the weekend. So to remove salt molecules from seawater, you're going to apply extra or external pressure on the other side to promote water to how do we call this, to move from a region of higher salt concentration to that of lower salt concentration, right? So this is reverse osmosis is the only means by which you can desalinate water among the given options, correct? Thank you, Sriram. So question 4, a 13-gallon air compressor costs rupees 18,000. How much would an 80-gallon compressor cost if the size component is 0.67? So I want you to think a little, figure out the formula that we are talking about here. So this is, falls under the costing part of, I think, second lecture. Again, I'll be waiting for an answer before we do it together. Okay, any guesses? If you remember, we have done a very similar problem in probably week 2 or 3, where we used zero point 0.6 as a size exponent. Now we're using 0.67. So I've taken this from one of the tables in Sir's lecture. Okay, let me write down the formula, and after that I expect an answer. Okay, so So do you remember this? Let me write here again. Cost 2, cost 1, maybe I'll write it as cost B by cost A is equal to size B A whole power n. So do you want to solve this and tell me? You already know three variables. You just need to find cost B, right? So what does size exponent here mean? So this is the ratio of size. We have an exponent here. So this is your n, right? Still waiting for an answer. Come on guys, we have to do this together. Okay, let's take size A as 13 gallons, size B as 80 gallons, cost A is equal to 18,000. What is cost B? And you know n is equal to 0.67. So cost B is equal to cost A into size B by size A whole power n is equal to 18,000 into what is size B? 80 gallons by size A is 13 gallons whole power 0.67. Don't mind my handwriting. Let me know if anything is in it. It's not legible because I didn't have a proper. Thank you, Urja. Would you like to recheck your answer? So think about this. 13 gallons is 18,000. So 80 gallons is supposed to be costlier than that, right? At least by 4 times. That's what you would expect. 3 to 4 times. So let's say that should be some 60 to 80,000. So you cannot get something in 2,397. Correct? So check whether you have made some mistake in raising it to the power of 0.67 or somewhere. Let me do it step by step because I mean last time that was a very silly mistake, oversight, right? 1.05 and 1.5, I thought they were the same while reading. So in a hurry you might do certain mistakes like that. So I'm going to divide 80 by 13, which is 6.1538. So I'm going to round it off to 154 whole power 0.67. So this I'm going to multiply by 80,000 into Urja. Do you have another answer for me? 6.154 whole power raised to the power 0.67 into 3.3785. So I'm going to take it as 3.379. 3.379 into 18,000, which is 6,822 rupees. Rupees there. Correct? Is everybody getting the same answer? So the answer that we got was 60,822. 22. Clear? Everybody got this answer? Shall I move on to the next question? We had just rounded off things. Okay. So I'm going on to question 5. Decreasing molecular weight of polymer in aqueous two-phase extraction. Option A decreases partition. Option B increases partition. Option C partition remains same. And option D partition stops. Remember, it is decreasing molecular weight of polymer. So what does that do? Take half a minute. I mean, definitely the molecular weight of polymer has got something to do with aqueous two-phase extraction. So it's neither remains same nor stops. So there I have reduced the options for you. It's either A or B. Just tell me what it is and we'll look into the answer. Take a wild guess. You have 50% chance of being right. And this was anyway explicitly told in the lectures also, I guess. Sriram? Okay. Okay, do you want me to solve that, Sriram? I can do that. Yes, sure. So, what about question 5? Do you have an answer, A or B? People other than Sriram and Urja can also participate. There was a statement, right? With increase in molecular weight of polymer, the partitioning of solvent decreased, right? From 400 to 4000 peg. It decreased. So what? Decreasing molecular weight of polymer would increase partition, correct? So the answer is 5B. So, Shriram, do you want me to uh, continue or let's see? So, for the record, Shriram has posted in chat a question. An antibiotic 30 mg is extracted from an aqueous broth with solvent K is equal to 8. So 30 mg is in your feed, right? And K is 8. What is the percent extracted if broth and organic solvent amounts are the same? So S and F are same. Okay, let's solve it here. I mean, if you're talking about the current assignment, I'm not following what's going on. I mean, we are different teams. Okay, so let's see what Shriram just said. Or maybe I can go into this mode again. So this is in week 6, is it, Shriram? Antibiotic 30 mg is there in uh, is your XF, correct? And XR is, we don't know. And what are they asking? Percentage extracted. So XR minus XF by XF into 100. This is your to find. And F is equal to S and E is equal to SK by F. So since these are the same, E is equal to K. What is K? K is equal to 8. All right. Now what do you have? XR by XF is equal to 1 by 1 plus E, or XR is equal to XF divided by 1 plus E, which gives us, what is XF? The TMG. 1 plus, I'm sorry, today I'm not having a proper bench to keep my writing device, so my handwriting is a little bad. So XR is equal to 30 by 9, so that I can take it as 10 by 3. What is that? 3.33, correct? Am I right? So XF minus XR by XF is equal to 30 minus 3.33 divided by 30. What is that? 30 minus 3.33 is 26.67 divided by 30 is equal to 0.889. So in percentage that would be 88.9%. Acha, I think you have taken one more 3 here. So that must have given 88.89. Not a big thing. But yeah, I'm also getting your answer only, Shriram. But it shows correct answer as 79.9 to 80.1. I mean, they might have made a mistake while uploading answer key, because we had a similar situation, right, in week 5 or something, where we were breaking our heads with what went wrong and the answer key was a little off, right? So that might have happened again. You can raise this issue and ask a question. I don't know if you have already done that. If you haven't, one of you can raise this issue and ask a question portal, and I think they will look into it and maybe grant you all marks for that particular question. Okay, so if you have worked out the way I have done, I mean, I'm getting the same answer as you have. So let's proceed into our next question. Question 6. So we are back to this week's uh, questions. Increasing molecular weight of a polymer in one phase decreases the concentration of the protein in that phase. So we just solved that question, right? Decreasing molecular weight increases partition. Increasing molecular weight decreases partition, right? So here, increasing the molecular weight of polymer in one phase decreases the concentration of protein in that phase, as concentration is equal to A minus B log molecular weight. If the concentration of the protein is zero point 0.2 and zero point 0.1, when the molecular weights of polymer added are 10,000 and 4,000 respectively, what is the concentration of the protein if I have a polymer of 30,000 molecular weight? So this is a classic quadratic equation problem. So I want you all to substitute the values given in the question and give me an answer, and then we'll sit and discuss. I mean, I think there are just 7 questions for this week, so we just have 2 more questions. I have all the time in the world, so I'm definitely waiting for one of you to answer this. So you use whatever information is given to find the values of A and B, then substitute A and B and the molecular weight and find concentration. That's all that we are going to do. So I'm going to start writing given here. So for the first equation we'll be doing 0.2, 0.1. A minus B log. For the first case it is 10,000 and second case it is 40,000. Don't mix up these values. You can check it by higher the molecular weight, lower is the concentration. Right? Lower the, the one with lesser molecular weight will have higher concentration. So if I solve this, I get 0.2 is equal to A minus B into, let's hold the B here and find the value of log 10,000. 4 zeros, so that should be 4, right? Log 10,000, let me check. Log of 10,000 is 4. A minus 4B. I hope all of you have your scientific calculator handy, otherwise it's going to be hard keeping up. 0.2 is equal to A minus 4B and 0.1 is equal to A minus, what is log of 40,000, that is 4.6. So what are we going to, writing this again for better, minus 4.6B equal to 0.1. So like how we solve quadratic equations, we cancel this out. So since I've made this positive, or we are subtracting, this becomes positive. 4.6 minus 4 would be 0.6B equal to 0.2 minus 0.1 would be 0.1. Keep checking my steps, guys, because I've been wrong once, I could be wrong again. So like silly oversights can be avoided. Keep checking whatever I write. 1 by 6 is it 0.16 or something? 1 divided by 6 is, yeah, 0.166. I'm going to stop with 3 decimals. So if B is 1 point, what will A be? 0.166. A is equal to 0.2 plus 4 into 0.166. So that is 4 into 0.166 is 664 plus 0.2. So I'm getting my answer as 0.864. Is that right? I'm going to substitute into this and check because I don't want to be wrong again. 4.6 into 0.166 is 0.7636. What is A? 0.864 minus answer is 0.1, right? So let me put that in red. So here we have A is equal to 0.864 and B is equal to 0.166. So I want you all to come from there to the next set. What is the concentration of the protein if I have a polymer of 30,000 is equal to A minus B log of molecular weight is equal to 0.864 minus 0.166 into log of 30,000. So first I'm going to do log of 30,000 is 4.477 into 0.166 is 0.7432. So the answer is 0.12 is what I get. Is that what you all get? Did you solve with me? Clear? Okay, yeah, we got 0.12, so it's fine. Should we proceed? Last question of the week. With reference to the reverse micellar extraction, which of the following statement is false? But they're asking about false. Option A, solubility of protein is dependent on surfactant's pH. Change in surfactant concentration directly affects the solubilization of proteins. So, talking about surfactant concentration. Nature of surfactant, ionic or non-ionic, determines the size of reverse micelles formed. And option D, higher ionic strength leads to the formation of larger reverse micelle. So which of these is false? Take a minute. Option A, solubility of protein is dependent on surfactant's pH. Is that true? pH, temperature, amount of surfactant, nature of surfactant all have a effect on the process of extraction, reverse micellar extraction, right? A, B, C, or D. Not even a guess. So I just give you a hint that all these are having an effect on extraction, right? Surfactant concentration, the more you increase, the better is the extraction process. So that's where sir said you have to trade off between the cost that you are willing to put into it. I mean, the cost involved in buying the surfactant and how much is the product's worth. And pH definitely determines whether your protein is going to be, I'm assuming protein, but whatever component that is that you wish to extract is positively or negatively charged, right? So pH has a very important role in determining how soluble the proteins are going to be and how well whatever surfactant that you are using is going to be effective in the process of extraction, right? And change in surfactant concentration, yeah, I just mentioned that. Nature of surfactant, of course, ionic or non-ionic, determines the size of reverse micelles formed depending on what is the pH of that particular solution or how is the nature of the whole two state aqueous and inorganic system, right? And the pH will also determine how I mean what is the charge of that particular protein, correct? If the pi is here of a protein, pH above the pi is going to lead to negative charge. pH below the pi of a protein is going to leave the protein positively charged. So if I have a positively charged protein and if I have a cationic uh, surfactant, obviously it's going to repel, right? So I should choose an anionic detergent. Similarly, whether I use an ionic or non-ionic will also uh, how do you say, influence the size of reverse micelles formed and the nature of extraction process, right? So the only option that you need to focus here is option D, higher ionic strength. So by ionic strength, what do you mean? You mean that we're going to add salt in the medium, or either you add it externally or it is already present. The fermentation broth will have its own salt, or maybe it has gone through certain processes, let's say like chromatography or some other extraction or salting out or precipitation. Therefore, the solution as a whole will have a lot of salt. And what does salt do? Let's say if it's a protein that we are trying to, or some charged or ionic species that you are trying to extract, so the surface charges that it has, either positive or negative, is going to be screened or masked by whatever salts you have, because salts ionize in liquid, right, in water, right? So it is going to have some Cl minus or Na plus is going to get attracted towards this region of surface where there is a negative charge, or this region of surface where it has a positive charge. So the chloride or negatively charged ions are going to come here. I've taken a normal example of sodium chloride here, right? By electrostatic interactions they are going to mask the charge. So as a whole now it is no more positive and this is no more negative, because it has been compensated by the arrival of ions in the solution. So you only have plus 2 instead of what might have been plus 3 before, right? So if I have a lot of salt, then it is going to act like an uncharged species, right? Leads to the formation of larger reverse micelles. So reverse micelles, if they are ionic, uh, let's say if there is no attraction or repulsion there, or any ionic interactions, the higher salt concentration is inhibiting the formation of a large reverse micelle. With increase in salt concentration, it is found that the size of reverse micelle decreases and the efficiency of extraction also decreases. Right, so the correct answer is high ionic strength leads to the formation of smaller reverse molecules, or the larger reverse micelles is a false option. So you always try to keep the ionic strength in the solution low, towards the lower side and not the higher one. Okay, with that, I don't have any more questions to present to you for week 7. In case you have anything else to clarify, like how Sriram brought up a question from week 6, this year's assignment, the ongoing assignment. If you have anything else that you want me to look into or solve for you, you can bring it up now. Otherwise, we can close down this session. Thank you all for joining. I'll wait for another minute until you guys decide whether to ask me something or not. I hope you were clear with week 6, question 8, 9, and 3 that we discussed at the beginning of this lecture. Not really lecture, sorry, it's a live session. That's it. Okay, then shall I stop sharing my screen? Yes, Madam, problem 6. So, Natarajan, you want this week's problem 6, right? Week 7. Okay. Let me do it fresh here, surrounded for you. This screen is visible, right? Do you want me to go into presentation? It's fine. Just do that. So they're giving you two situations. Increasing molecular weight of polymer in one phase decreases concentration as this equation. So this is how the concentration varies with molecular weight. Okay, and they have already given you two cases. If the concentration of protein is 0.2 and 0.1, when the molecular weights of the polymer added are 10,000 and 40,000. So they have given you molecular weight, they have given you concentration for two cases. So what is this? When you have two variables A and B, you need at least two equations for you to find the value of A and B. So to find that, they have given you two sets of concentrations and two sets of molecular weights. So what are we doing here? We are substituting concentration 0.2 is equal to A minus B into log of 10,000. So this I know it as 4. So I get my equation as A minus 4B is equal to 0.2. Clear here? So this is my equation 1. Second, 0.1 is equal to A minus B log of 40,000. I am doing nothing. I am just using the given here and substituting into this particular equation. And my A and B are still A and B. And log 40,000 was 4.6. Okay, so this part is 4.6. So I'm just bringing it to the left side. A minus 4.6b is equal to 0.1. This is my equation 2. So I'm solving. Let me go to the next line. I don't want you to get confused again. So I'm using this. Tough. Yeah. So 1 and 2. A minus 4b is equal to 0.2. A minus 4.6b is equal to, if you are confusing with b as 6, I'll write it again. B is equal to zero point 0.1. So how do you subtract these two equations? Minus, so this becomes plus, this becomes minus, right? So a minus a is 0, minus 4 and plus 4.6. So I have plus 0.6, b is equal to 0.2 minus 0.1 is 0.1, which gives me b is equal to 0.1 by 0.6, or 1 by 6 is equal to 0.166. Same thing I can do. A minus 4b is equal to 0.2. Instead of solving for A, how would I do B? I have to multiply with so many things. So instead of solving for this again and equating B to get A, I just substituted the value of B. Yeah, I can do like this, right? A minus 4B is equal to zero point 0.2. So I'm putting B as 0.166 here. So A minus 4 into 0.166 is 0.664 is equal to zero point 0.2. So I'm taking this to the other side. A is equal to 0.664 plus zero point 0.2 is equal to 0.864. So you have found out the value of A. Yeah. So you have found out A and you have found out B. Now they're asking what is the concentration? There is my pen. Okay, I can't see. So what is the concentration in the protein if I have a polymer of 30,000? So what do I have? Concentration is equal to A minus B. A is 0.864 minus B 0.166 log of 30,000. So log 30,000 is equal to 4.477. 4.477. So I'm multiplying that with 0.166. That's giving me 0.7432. When I subtract 0.864, that's the answer. I'm getting concentration of zero point 0.2. Is that clear, Natarajan? Okay. Anything else, guys? That's it. Okay, I'm going to close this down. Meet you all in week 8 next Friday.